Okay, so our first question is on page 32, number 13B and C. In how many ways can the 5 starting positions on a basketball team be filled from these groups? So the key to understanding this question is knowing what kind of players are on a basketball team. So there's 1 center, 2 forwards, and 2 guards. As far as I know, I don't follow sports very closely, but this is my understanding. So in 13B, only who two players who can only play center. So 2 players can only play center, and 8 others who play any of the other positions. Okay, so we have 2 players who can play center, so we're going to have to choose 1 person out of the 2, and then we have to choose 4 people out of the 8 for part B. So in 13B, out of the 2 people who can play center, we're going to choose 1. And they only play center, so they can't play forward or guard. So then there's 8 others who can play any of the other 2 positions. So this is your center, and this is forwards and guards. So if we were to work that out, 2 choose 1 is 2 times 8 choose 4, and I get 140. And I'm hoping that's the answer. Let's see, 14, 13B, 140. Okay, good. And now 13C. So in 13C, 2 people can play centers, 4 people can play forwards, and 4 people can play guards. So we need 1 center, so we're going to choose 1 center. We need 2 forwards, so out of the 4 forwards, we're going to choose 2 forwards. And out of the 4 people who can play the guard position, we need 2 more. So when we calculate that, we get 2 times 4 NCR2 times 4 NCR2, and we get 72. Okay, so that was 13B and 13C. Number 14. There's 14. From a group of 14 conservatives, okay, so I'll just put 14 here. From a group of 14 conservatives, 12 liberals, and I just like to get the important information, 8 NDP, and 2 independent members of parliament. How many different committees can be formed using, we're going to need 3 conservatives, 3 liberals, 2 NDP, and 1 independent. Okay, so that kind of helps us set up how many ways we can fill in these members. So we have, out of the 14 conservative, we need 3. Out of the 12 liberals, we need 3. Out of the 8 NDP, we need 2. And out of the 2 independent, we need 1. So when I plug that into my calculator, I get 14 NCR3 times 12 NCR2 times 8 NCR2 times 2 choose 1 is just 2, so I get 1,345,344, and hopefully that is the answer to number 14. Oh, okay. Did anyone get this answer? Oh, oh, what did I put in? Oh, did I? Okay. Let me just double check, and thank you for pointing that out. I appreciate it. So 4,484,480. Okay, better? Thank you. Okay, the next question was 15. Okay, so for poker hands, it's important you understand a little bit about a deck of cards. So how many poker hands? A poker hand has 5 cards. Are there with 3 aces and 2 kings? In any deck of cards, there are 4 aces and there are 4 kings. Okay? So that means we need 3 aces, so 4 choose 3 and 4 choose 2. So how many poker hands are there with 3 aces and 2 kings? That's a really good hand. Any poker player would die for that hand, I would think. So 4 NCR 3 times 4 NCR 2, and I get 24 ways that can happen. Okay, so hopefully 15, we're good with 15. Okay, so now we're moving on to question 19. Which one in 19 would you like me to do? They're asking us to solve for n. Oh, sorry, yeah, 19, there's 4 parts. Can we maybe pick one part and take it from there? You guys tell me which one in 19 you want me to do. Sorry? Part A and D? Okay, let's do A and D. So we have n choose n minus 2 equals 10. Okay, so the NCR formula, which we're using here, is n factorial over r factorial n minus r factorial. So we're going to have to sub that into the formula before we can, and then we'll get rid of any factorial notation, and then we'll solve for n. So we have n factorial all over n minus 2 factorial. Our r in this situation is this, right? And then we're going to have to do the top one minus the bottom one. Sure. Okay, I'll get rid of the book and then I have more flexibility here. And that equals 10. So we have n factorial all over n minus 2 factorial, and n minus n is 0, a minus and a minus is a positive, so that's 2 factorial equals 10. So before we can solve this equation, we need to get rid of the factorials. So just like before when we did permutations, I'm going to bring the numerator down to the denominator so I can divide things out. So the numerator I'm going to write as n times n minus 1 times n minus 2 factorial all over 2 factorial times n minus 2 factorial. I just changed the order, but that doesn't change anything. Now I can divide this out, right? Those divide out. So I'm left with n times n minus 1 over 2. 2 factorial is 2, that equals 10. The next thing to solving an equation is I want to get rid of any denominator, so I'm going to multiply both sides by 2. And so now I have n times n minus 1 equals 20. So I'm going to solve this as a quadratic equation. So it's n squared minus n minus 20 equals 0. So that would be solving by factoring n minus 5, n plus 4 equals 0. So n equals 5 or n equals minus 4. So n cannot be minus 4 because factorial is not defined for negative numbers. So this is inadmissible. right? We can't use that one. So therefore, n equals 5. So that was 19A. Let's now move on to 19D. 19D, we're solving for n, where n is a natural number, okay? P n comma 4 equals 60, n minus 1, choose 3. So now we have one equation with the permutation and as well as with the combination. So just remember, P n comma r equals n factorial over n minus r factorial, and n choose r equals n factorial over r factorial n minus r factorial. Okay, so there we go. So let's sub it into our formulas, and then we can get rid of our factorials, and then we can solve for n. So we have n factorial over n minus 4 factorial equals 60 times n minus 1 factorial over 3 factorial times n minus 1 minus 3 factorial. So far, so good? Okay. So, okay. So, I'm going to simplify. Notice this is n minus 4 factorial. Just let me write this out, and we'll be able to get rid of that n minus 4 factorial, which will be nice. 60 times n minus 1 factorial over n minus 4 factorial. So notice I can right away get rid of the n minus 4 factorial by multiplying both sides by n minus 4 factorial, and I'll multiply this side by n minus 4 factorial. So whenever you're solving an equation, what you do to the left hand side you have to do to the right hand side. Otherwise you lose this equality. So I'm treating each side consistently. This divides out, and now I'm left with n factorial equals 60 times n minus 1 factorial. Yeah? Oh, did I drop the free? Okay, so can I just squeeze this one in here? So this should be over 3 factorial. Is that? Thank you very much. Okay, so I'm gonna need to divide out the n minus 1 factorial, so I'm gonna write this left hand side as n times n minus 1 factorial equals 60 times n minus 1 factorial over 6. So this is beautiful because I can divide both sides by n minus 1 factorial, so those will divide out, right? If I divide this side by n minus 1 factorial and this side by n minus 1 factorial, those divide out. As long as I do to the left side what I did to the right side, we're fine. So this leaves me with n equals 60 over 6 and n equals 10. So that was number 19D. 19D. Okay, good. Right, so that was quite an involved one. The next question was number 20. Okay, because 20 is more involved. So question number 20, oops. Question number 20, which one in 20 would you like me to do? You guys decide. I don't want to do all of them, but I want you to tell me which one to do. Pardon? C is in cat? C is in cat? Okay, we'll do part C. So, oh, sorry, this one here. So notice this one is a proving question. Whenever you prove, you have to separate the left side from the right side. You can't assume it's true unless you've proven it. Okay, so here we go. 20C. So we have r plus 1 times n plus 1 over r plus 1. So it's n plus 1 choose r plus 1 equals n plus 1, and that's n choose r. So let's work with the left side, and then we'll work with the right side and see what we can do to see how we can maybe algebraically work with them to make them equal. So left side equals r plus 1 times, I didn't want to do that. Here, let me just white that out. This is going to be n plus 1 factorial all over r plus 1 factorial times the top minus the bottom, n plus 1 minus r plus 1 factorial. Whew, that's got to really keep your wits about you when you do some of these things. So this is r plus 1 times n plus 1 factorial all over r plus 1 factorial, and this will be n minus r factorial, right? Because plus 1 minus 1 is 0, so this works out to be n minus r factorial. Now I can go a little bit further because I can see that I can do some simplification here. So let's do this. This is equal to r plus 1 times n plus 1 factorial, and that's as if that was 1. So I'll just put all this over the same denominator. I'm going to split this up to r plus 1 times r factorial times n minus r factorial. So this divides out, and then we're left with n plus 1 factorial over r factorial times n minus r factorial. Okay, so I can't do any more with the left hand side, so now I'm going to work with the right hand side. The right hand side equals n plus 1 times n choose r, and that's n plus 1 times n factorial all over r factorial n minus r factorial. Okay, can you see this is the same as n plus 1 times n factorial is the same as n plus 1 factorial all over r factorial n minus r factorial. Oh, okay. Left side equals right side. That guy equals that guy. So we're doing pretty good here. So it's just slowly, you have all the, as complicated as that looks, you have all the tools to just follow through algebraically and do all of that. Is that okay for 20? Let's move on to 21 and 22. Okay, so I think for number 21, it's important to know, just ignore that what's up at the top. I was just showing something to my other class yesterday. So let's look at 21. The issue maybe with 21 is understanding a deck of cards. How many bridge hands contain exactly 5 spades? Well, in a previous question, we're told that a bridge hand has 13 cards, right? So in number 21, they're asking, so we need 13 cards in total. But of those 13 cards, we want exactly 5 spades. The important thing to realize is that there are 13 spades in a deck of cards. Spades look like this. I'm not too good at drawing spades. Then there's 13 clubs. Right, and then there's 13 hearts. And then there's 13 diamonds. Okay, so there's 13 spades. There's 13 spades. And then there's 39, let's call them non-spades. Okay? So, if we want to choose exactly 5 spades, out of the 13 cards, we need to choose our spades, right? That's where I'm choosing the spades. And then I cannot choose any more spades or I won't have exactly 5 spades. So now I have to focus on what are non-spades. So out of the 39 cards, now I need 13 in total, right? So I'm going to have to choose 8 more cards. And this is the non-spades. Okay, so that should give us 5 plus 8 is 13. So we have our 13 card. 13 NCR 5 times 39 NCR 8, and I get some ridiculously large number. It's approximately, because we're losing a lot of accuracy here, times 10 to the 10. Oh, sorry, they said leave it in factorial form. Okay, so let's leave that in factorial form. Here I have it in combinatoric form. Let's put that in factorial form. So the 13 choose 5 is 13 factorial over 5 factorial. 13 minus 5 factorial is 8 factorial times 39 factorial over 8 factorial. 39 minus 8 is 31 factorial. Yes? Okay. Well, they only want 5 spades, right? So if they want, a bridge hand has 13 cards in total. So if they want exactly 5 spades, that means we have to make up the other 8 cards, which must be non-spades. So that's your answer to number 21. Okay. Then 22. How many ways can 12 prizes, here's 22, be divided equally? So there's 22. How many ways can 12 prizes be divided equally between 2 people, 3 people, and 4 people? Okay, let's look. I think if you understand how to do 22, you'll understand how to do 22A. You'll understand how to do 22A, B, and C. So how many ways can 12 prizes be divided? So if it's between 2 people, that means each person gets 6 prizes, right? Because there's only 2 people, there's 12 prizes in total. So each person gets 12 prizes. So that means the first person gets 6 of the 12, and the next person gets the remaining 6. So 626 is 6, so 12 is equal to 924. Now in part B, if we want it among 3 people, each person gets 4 prizes for a total of 12 prizes. Okay, so the first person gets the 4 prizes. Then out of the remaining 8 prizes, the second person gets 4 prizes. And then out of the remaining 4 prizes, the third person gets the remaining 4 prizes. So that's the way you would divide that up. And I get 34,650. Is there anything else I can elaborate on or explain any better? Zane? Oh, 19B, we got a different answer. B is in Bob. Okay, let's look at 19B. Maybe I'll put that one down here. Okay, so we're good? Okay, good.